done is kind of taken the tools and the things that we've developed over the 20+ years and created a real-time online monitoring package out of that. So it uses the capabilities of MeScope and puts that into a monitoring package and a new interface for that package, which allows you to access data from your machines running real-time anywhere throughout the world via the internet. So we'll just go really quickly over what's going on underneath the hood. This is MeScope. The way simulated data, but 4 machines in theory are being monitored at one time. And like I said, it's unlimited channels, so if you want to throw 500 channels on one machine, you can certainly do that. But I'll just give you a quick overview. In MeScope, this program is set up for you. We'll build you a custom program upon installation that's going to do what you want it to do. It's set up to acquire data for the type of channels you want, whether that be vibration, temperature, pressure, whatnot. We can do multiple order tracking for you. We can curve fit the data and do operational modal, vibroacoustic stuff. It just depends on what you want. But again, it's set up for you, as are the models, the 3D models, which we'll get into next. But upon acquisition, there's acquisitions running here along this middle section. This is the acquisition windows within MeScope. We're doing 3 averages, and each one has a program, a macro program that's built into it, and it's just running through the different tools that are within MeScope. And all these are doing ODS. Some of them are doing multiple order tracking. But I just wanted to give you a glance of what's going on under the hood and what is actually being done when your data is acquired and post-processed prior to being pushed into the database. The other portion of MeScope, or of MechaniCom, sorry, is what is the console, and this is where, you know, the operators and people that want to check on the data and check up on machines, this is where you're going to spend your time. The way it's designed is MeScope will just run continuously or just run based on a period if you only want periodic acquisition, but it'll just run in the background and you never have to touch it. That data passes into an SQL database and then accessed either remotely or directly. That database can be accessed with the MechaniCom console here. This is your machine gallery. Like I said, we're just doing simulated data for 4 machines here, but you could have all your machines here. You could have it broken down into individual locations if it's being measured at different sites. It's your preference. But this is what we call the machine gallery. It's basically just a quick glance. You can kind of see the LED icons here. 3 of the 4 in the green. This one's in an alert stage. Again, simulated data. It's just cycling through the same type of data over and over again. So you're going to see these displays cycle through. A little bit of information here tells you that the machine is on, that your acquisition is running, the last update for the time and date, and how long it's been between the last acquisition. So you're going to see these acquisitions run, you know, every 5 seconds or so, every 7 seconds, and that's how quickly the data is being acquired and post-processed. And so your alarming and all your updates, that's basically the interval you can get, 4, 5, 6 seconds, sometimes faster. A lot of it just depends on your processor power. From this place, we can open up individual machines and get a more detailed view at what's going on with them. So we'll open this aerial reciprocating compressor here. You can see on the rotating model there's icons, and when I hover over them it gives me the gauges of the status for what's going on. You're looking at your orange pin is the baseline value, or I'm sorry, the green pin in the gauge here. I'll make this one bigger so you can see it. So the green pin here is your baseline value. The orange pin is your current value, but it displays your alarming level. So your green, this is in inches per second for velocity, The green's just going to show, you know, your green area, the good area. Your yellow is going to be your alert area. Orange will be your alarm, and then above that will be your report area. We don't have any trips, any sort of electronic trips, so this is just more for reference. I'll show you in the trend plots how in the trends you can put your warning level gauges across and look at that more closely. But let's look at the gauges first, since we talked about that. There's different types of gauges that we allow. You can resize them. We can certainly rename all of them on the headers so they're more identifiable to you, becomes specific to you. Other types of gauges, we have a generic kind of LED one. This happens to be measuring RPMs or operating frequency right now. Again, you know, the C lists the current value, which is about 1900 RPMs, and the B here would be the baseline. So the baseline's a little bit higher than that, so it's actually functioning a little bit below the baseline. But obviously, it's not outside of our thresholds. We have vertical type gauges in here. I'm using them for the temperature. So inboard and outboard bearing, we have, you know, measured here. Both of them are the green. Again, C for currents at the top, B for baseline. Temperature data in this one. Again, we have, you know, on these are labeled as cylinders, horizontal, vertical, and axial. You can see there was a shift here. So we're actually up in the orange here, and that'll be indicated on the model where I showed you the icons. The gauges are just a quick reference. It's a good way to see current versus baseline and where your data for individual measurement points are falling at the time. You can break different gauge panels for multiple orders. And you can look at the multiple orders on different gauge panels. You can create custom gauge panels. One of the nice things that we offer for multiple orders, and I'll show this in a few minutes, is that you can create different alarming levels for the same measurement location, but you can create them different alarming levels for multiple orders. So if you're looking more, you know, bearing related stuff, it may be the third order. You can tighten it down instead of leaving it where you would be for running speed for, you know, your threshold, which you would want higher. Obviously, you're going to see the highest peak there in most cases. If you want to be more sensitive to a magnitude change at the higher orders, you can have a tighter alarming limits there. So you have higher sensitivity, and it'll let you know that something's going on, even though at running speed maybe your magnitude didn't change. You have sensitivity up at higher orders, and it'll alert you that way. We have text message and email alerting, so anytime, you know, you cross any sort of warning level, you're going to get that alert. It's going to come to you on your phone. It's going to come to you in your email. You can add as many emails and text messages as you want, or phone numbers as you want, and kind of dictate who is getting that indication. Let's go over the model next. Very similar to Emiscope if you've used it before. It's built down into substructures. We can make certain substructures transparent if we want to look through them. So you can see that gearbox there went transparent. We can make, you know, one of these suction bottles transparent. We can take them away if you want. So similar drawing tools as in Emiscope. We can go to quad view. You know, zoom in and out here. And like I said, you know, you hover over the icons, it's going to give you the gauge or gauges associated with that icon there. You just got to get a quick glance. Model's a good reference. Also, we do offer full ODS animation. If you have enough, you know, measurement points and enough data to do full ODS animation, then we do offer that. It works exactly the same as it does in Emiscope, where, you know, if you have 30 points or so of data collected, we can animate it using interpolation. Again, the 3D model of your structure is included as part of the purchase price and is set up for you, so it essentially becomes a plug and play. Now you need to set your own warning limits, you know, set up your phone numbers and emails, and we can also help you with that. But as far as what needs to be done to get up and running, it's just really getting the model in here and getting the programming in Emiscope set up for you to acquire. acquire and post-process that data. We'll look at the trend plot now. Traditional trend plot, as I kind of talked about, you can overlay your warning levels. So here's our alert, our alarm, and our abort levels. We have them there. They're indicated in the legend also. You can select what you want to display, what measurements here. If you want to put temperature and, if you want to put two unlike quantities on the same graph just to gauge them, we can make temperature so it's using the right axis, and you'll see the temperature show up there. So you can plot, even though they're not using the same units, you can plot vibration and temperature together on the same chart and just look for correlation in that way. Again, this one has multiple orders, first and second order. I can plot just the trend data from the second order. Do different things from here. I can hide the labels if I want on the Y and X axis. Right now I have it set on a relative x-axis, meaning that if I have big gaps in my data acquisition, or if maybe the machine turns off at night, I can look at the data only when the machine's been running, or I can make the data so it's uniform, so it'll show me when it's been off, which the line, the trend lines will all cycle to the bottom, and then they'll come back up when the machine goes on. So you have both those options. We can export anything in here, whatever we see visibly on here. We can export it to PDF, to a PNG file, or also to CSV for further use in Microsoft Excel. We can change the different plot types in here. We can go to vertical bars, filled chart there. We can smooth it out. We can just go to individual, acquisition points. Different ways you can look at it. Let's see. You can mark events or display events on your chart there. So anytime you come across an event, whether you save the event as a manual event or it's something that's an alarm event, it's going to be saved in an event log. And what you can do is display those events so they'll identify themselves as markers in your trend plot so you can see them when they occur. Obviously, if I turn those on, it should. I don't have any events set up to mark right now. But they would show up in here, and you would see them indicated, when they breach the thresholds. We can create an event. We can just say, hey, test. I'll add it here. Oops. Yeah, I don't have it set up there. Other things that we can do, there's a plot options window that I turned off there. We can have the thumbnail overview, which will show you down here what's going on. It gives you the ability to zoom or just grab certain areas, certain windows, and slide around in your data. Lots of different options. Traditional trend plot. If you have more questions, I can show you more of what's in there. Frequency traces is kind of the same way. It's something that you're used to. I have the frequencies and the multiple orders indicated by vertical lines. The dashed lines in the background are your baseline magnitudes and frequencies, so you can see that there's been a shift away from that right now. Just a good indicator that way. Similar thing, we can cycle through the different display types, real, log, magnitude, similar to what you see in EmiScope. Other things, we can select which channels or basically what data acquisition points we have. We can select those for display on here. We can turn it on and off. We can change the colors. It's obviously, one of the first things you look at when you're trying to identify any sort of faults or do any sort of analysis is you're going to look for different things, sidebands popping up at higher orders, changes in magnitude, shift in frequencies, those type of things. And this is going to be the first place you look. So it's typically one of the 4 panels that you always have up on your screen. And that's basically where I started there, was the 4 panels that you probably use more often. So that's kind of the generic look there. Other thing I said, we do have an event log. Which will give you the event. It'll give you what warning level, tell you the type, whether it's a manual event that you input. Maybe you got, everything realigned or rebalanced, and then you wanted to set a new baseline. You can do that. You can create events when you see something that's strange, or maybe you have scheduled shutdown. You just want to indicate that. You can create your own event. But this was a warning level violation. It tells us where we were. We were on cylinder 1 horizontal. It's at the alert level. The baseline value is 27/100ths of an inch per second. Obviously it's right near the threshold. The current value is at 28, and the low is at 25. So it just went up. The baseline set even above the low boundary. So that's where we are with that. But things that you can do, we're set up to recall basically 5 acquisitions before and 5 after, and you can change that if you want to save more acquisitions before and after a warning level. But what that allows you to do is you can pull up the trend plot associated with that particular channel and its violation. You can see where it was, where the violation was. We can do the same thing with traces. Same thing. It's going to take that channel. It's going to show you, where it shifted. So it looks like there was a little run up here, and it ran up higher. But all that stuff is recallable from here, and it saves it. And like I said, what you can do is you can set how many basically acquisitions before and after that event it'll save with it. And these events will stay here either until you delete them, or you can kind of set the buffer for it. Generically, it comes as 100 user events and 100 warning level events. You can make that bigger or smaller depending on how many you want to save, but you can delete them straight from here also if you want to. One thing, I don't have it set up, but we do have it on the price list, and it is sold. We do have camera. It opens up in the same window as here. It's all streaming video and audio that passes through. You can manipulate the camera head for the one we save, so you can pan and zoom. Obviously change the volume on the audio. Unfortunately, I don't have a camera set up where I am, so I can't give you a demo. You'd have to just look at me also, but we do sell that camera option. So it's there. It's for installation. It hooks up via just a Cat5 cable, plugs right into one of the MechaniCom yellow boxes if you go that route. So it's all power over Ethernet, easy to use. Let's talk about let's talk about some settings real quick and things that you would do for settings here. You can change the machine name. If you have a camera like we talked about, it would have its own URI, username and password, so nobody would be able to access it but you. All that would be controlled from here. For email and text message notifications, that would all be set up in here also. So you can add multiple addresses through email notification. You can test them first. Same thing with phone numbers, the phone number, the carrier, and then you go from there. You can set what notifications you want to use. On temperatures, maybe, or frequency, maybe for a tachometer, maybe you want to set your alert, alarm, and abort levels above and below that frequency. Maybe vibration, if you're just using velocity, you just want to be above. And that's all if you're using relative or absolute, I'm sorry. We also offer the option to use relative alarming, which would mean that you set the number that it's relative to your baseline measured amounts. Your thresholds are set to that. So if you want to set for a percentage away from your baseline for temperature, if your baseline temperature here, roughly 75 degrees, if you wanted to set a % away each of those levels, you can do that, and I'll show you how to do that. Or you can set values, relative to that baseline. But most of the time, we just work in absolute values, and that's kind of the standard that you would do. From this window, you also control what we call the FIFO storage. And we're well aware that database space and database usage is kind of a precious commodity. So what we do is we give you the ability to control how much, how often, how long, basically. We have short-term storage, long-term storage, warning level event storage, which I talked about, and then the manual archive event storage, which are the ones that you can manually input. What the normal installation is for this is we set the acquisition up so it acquires and post-processes the data as quickly as possible based on your machine. So as I said, somewhere between 3 to 7 seconds per machine. Your alarming and everything will be based off of that, and your alerts and any notifications will be based off of that. But you don't have to store the data that frequently. So it kind of gives you the ability to still have real-time monitoring, but not store the data as frequently as that, so it's not going to eat up your database space. Right now I have this set up so it's using the maximum rate, but what I could do is, hey, I want to do, maybe only want one acquisition stored per hour or something, and I want all those stored for 1 week. So what I would do here is I'd uncheck this box. I'd say I want, 1 per hour here, and I want to store it in the short term for 7 days. And so that's what I'd be now. I would just get, 24 acquisitions a day for a week. Now, in the long-term storage, gives you the ability to expand out what you'd see in the trend plot without eating up a bunch of data also. So what we're going to get in the long-term storage above, we had set that up. We said, hey, we're going to get 1 per hour for 7 days. So for the most recent 7 days, we're going to get 24 acquisition measurements a day that's going to display itself in the trend plot. Outside of that, maybe we want to go for the rest of the month or the rest of 6 months. We can set the storage rate for maybe only 4 times a day, once every 6 hours or so. And so we have database control in that way where we're not using up space. And as something cycles through, once we get past a week, it's only going to save every 6th hour of data, and the rest of it is going to be discarded from the database. So you do have full database control there. Warning level events, I kind of showed you that in the event log. We call them snapshots before and after the event. Those are the acquisitions. Right now it's set at 5. You can save more acquisitions or less before or after the event. It's up to you. Traditionally or typically it's set up as using the maximum rate so you can see the changes, but you don't have to do it that frequently. If you want the snapshots that are saved leading up to it, maybe you only want once an hour or once every 30 minutes, you can set that up in here for event storage, warning level snapshots the exact same way that we do with short-term storage. You can say, hey, I want 1 per hour or 2 per hour or whatever. And you can delete all events through there. Manual archive are events that you set yourself, and you can control them the exact same way through here. And this control is done on a machine-by-machine basis. If you only want to receive text and email alerts on a certain machine, or you want to control the database individually, how frequently you're going to store the data for each machine, it's done individually on each machine you monitor, so it's not broad sweeping at all. The same is true here when you set your warning levels. These will be for use machine, or basically on all machines. What we can do is you can create additional ones for whichever ones you want. We kind of have some ISO presets in here. Here you would check whether you want to use low and high alert levels. It's got the numbers. You can easily change them here. We want to change this value. We can change this to, it's already set on 0.3. We want to change it to 0.27. Type it in there. Save it. We would be good. I'm not going to save it there, but you can add additional warning levels. You can change them from here. You can control them. The stuff that I have been showing you is all what we call an administrator mode. So you're going to get different levels of access. You can assign different levels of access based on who you want accessing this. Anytime you're changing warning levels, you're changing database storage, you're assigning email and text message alerts, you want that to only be done at the highest access level. So that's going to be your administrator level. It's going to require username, password, just like any other sort of sign-in. But it protects your console and your setup from from being changed by anybody that you may or may not want to change it there. Again, this is how you would set additional email stuff. It's port name, or if you have protected email, if it's SSL enabled, this is where you would put additional stuff in there. If you want to change the administrator password for what I just talked about, which would be your privileged access, that would change here. It's recallable if you lose it. We can, always work a way to get back into it because it's stored in your database. But this is where you would control that. And obviously, to even change it, you would need to be in administrator mode to change it from here. Other things that you can change here. We have different themes in here. If you prefer a more old school look where you want black backgrounds, you can change to there. Same thing with the Metro, just different ones here. Which is more of just a white one, clean. It's up to you. Your choice is all fully changeable based on what you're comfortable with. We also have the ability to modify the time zone. Now, some people, mostly when it's set up in the time zone that you're going to see on your trend plots and on your event log are going to be local to the acquisition site, meaning that where that data is acquired, it's going to give you the time that's set up on that computer there. You can also set up to local time, which would display the data on the computer, on the time that's local to your iPad or local to your computer. So it's going to show you what's local to you. If you're looking at it from halfway around the world or from a different time zone, you can change it there. Also universal time code. So that's changeable there for you. And then a contact email for updates from us and stuff like that. You can change that there. I talked a little bit about being able to do multiple orders and change multiple orders. This is going to be set up here. All you have to do from your machine tree here is right-click on. Well, I got to be set up here. Why not set up here? I'm not sure what's going on. Oh, I'm not set up for that. So what you would do here is when you're at the higher orders, you right-click on the individual measurements. If you're using triaxial accelerometers, it's going to select one axis at a time, and you can go through and you basically assign the warning levels as I showed them to you to that higher order. So as we look here, we have multiple orders here. We have cylinder 1 horizontal here in the first order, which is going to be your running speed. In the second order, we have the same thing. As you can kind of see, this is at 1/4 of an inch per second, basically magnitude. This is at 1/1000th of an inch magnitude at their second order, so obviously much lower. So maybe we want higher or much tighter sensitivity as our orders go up. So what we do is we just create warning levels that are much tighter. Maybe we create these at 1/10 of an inch or 5/100ths of an inch per second, something like that. So it's tighter there, and it gives you greater flexibility to understand and be alerted when the change happens at higher order, even though the magnitude may not change at the running speed. So flexibility for things that essentially will allow you to diagnose issues, diagnose faults, or recognize faults more quickly than you may if you're simply looking at frequency traces. This is more of an automated process for you there. The last thing that I can show you is we have this called FACS. It's our fault correlation tools. Let me get this thing opened up here. Because the way this simulated data is set up, it's just going to continue to over and over kick into the same fault, so you're going to look at the red bar. But let me just explain to you how FACS works. What we've taken, some of you may be familiar with the MAC value or the modal assurance criterion. It's obviously related to mode shapes, and because of that, it doesn't take any magnitude changes into account. What we did is we developed something that we've termed the shape difference indicator, which it's more for ODS use, and it takes magnitude into account, and it can also incorporate scalar measurements, so temperatures and pressures, different measurements of volume, things like that. It can take all those into account. What it does is it accounts for magnitude changes, changes in frequency, things like that. And what it will do is it will take any event that you previously had stored. Let's say that you had an unbalanced situation that occurred before. What you would do is you would run FACS. FACS would compare your current data, what's currently in the buffer there, and it's going to compare it against all your event storage there. If you have a situation where your machine is now exhibiting kind of the same symptoms that it had before as your previous unbalance, your bar is going to grow. The red bar indicates very strong correlation. The green bars are lower correlation. But what you'll see in that scenario, you have a previously saved unbalance. As your machine goes more and more unbalanced and it gets more and more in the same symptoms, the same scenarios, your previous unbalance, you're going to see those bars grow. And it's a great indicator for diagnostics. Essentially what FACS does is it learns your machine. So over the period of time that MechaniCom is on your machine and you have simple faults, a lot of machines have a lot of recurring faults, you're going to see those things there, and you're going to be able to give a clear bar indicator as that increases towards your previous fault. It's going to show it to you there. I don't have any of these events labeled, but when you do indicate a label or you have any sort of notes for a previous event, they'll show up there. So if I had an unbalance, maybe this here, it's not going to say the date and the time. It's going to say unbalance, or you can have the date and the time added, but it'll say unbalance, and maybe it was, however you listed it. You had a inboard or outboard bearing going bad, or you had soft foot or parallel or angular misalignment, something like that. You're going to indicate that stuff as your label, and that's what's going to show up here. And again, like we talked about, you can do, you can look at it as an overall. You can look at it broken down into orders. You can select what you want to check against, whether you only want to look at short-term storage, whether you only want to look at long-term storage, event storage. This is all fully flexible here, and you select things the way you want to select them from your plot options. So, Mark, should we open up to questions and we can go through some stuff? Or?
Sure. Yeah, let me go to unmute. Jose. Does anybody have any questions? Sean's done a pretty thorough navigation of the MechaniCom console here. We took a look at the MeScope program running under the covers. Can everybody hear me okay?
Yep. I can hear you. I can hear you, Mark. Good sound and laser.
Great, thanks. I'm getting a little bit of feedback here. Now we can send a 30-day demonstration of this out to you. In fact, you can just go and download the MechaniCom console. I believe all of you are current MeScope users, so you can download MechaniCom console from the Fiber Technology website, and then you can go ahead and just play around with this particular 4-machine demonstration that we're looking at here. You can download the MeScope program right from the website as well. Now we are recording this webinar, so we'll go ahead and get this posted as well up onto our Vibrant Technology YouTube site. And if you haven't had a chance to go out there, we got quite a few other videos for both MechaniCom and for MeScope. We had a advanced curve fitting webinar yesterday for MeScope, and I believe that one is out there as well on the website. Sean, you want to pull up the new website real quick? Just
Sure.
kind of show how to navigate.
Sure. We have just changed the website, so it's in the process of still being updated some areas, but same web location. You can get there from a lot of different ways. But if you're looking to get the downloads for the latest ME scope or MechaniCom, it's in the support area. I'll show you the upcoming events. The advanced curve fitting for Learning Lab was yesterday. Obviously, this is today's here. If you go in the support area under downloads, just give me your ME scope download there. It's going to be the latest. Same thing for MechaniCom. Console is here. MechaniCom server, which is the SQL database. Installation instructions for it there, and then the 4 machines project if you want to work it there. We also have a testing server where if you just want to download the MechaniCom console, we can give you the test server address for that, and you can connect just via the internet, and it runs the exact same demo that I just went through there. All the buttons and functionality and everything are there for you. You can't go through and you know, change the warning levels and things like that. But everything else, you can click through the panels. You can, you know, save PDF or save CSV files out of the trend and frequency trace areas. You can do all that kind of stuff. So if you'd like to play with it a little bit yourself, you can do that there.
John, I have a couple of questions, if more on the technical side of things.
Okay.
If that will be okay.
Yeah. Oh, please. Yeah. Absolutely.
Yeah, I've been sort of taking some notes here. I guess one of my questions is, well, first of all, the data acquisition, that the data that you're using.
Yes.
What kind of A to D have you got? Like, is it a 12 or 16 or 24-bit or?
Yeah, let's talk about that. It depends. If you have your own acquisition hardware, then
I have a diagnostic instruments DI440 that which was it became the SKF MX or GX.
right.
So,
So everything right now, if you have your own front end, like we just talked about, you did. Anything that we have an acquisition window already built for in ME scope, you can use that as a front end.
yeah, I've got Hewlett-Packard spectrum analyzer as well. I've got several Hewlett-Packard spectrum analyzers.
Okay.
As a matter of fact, I used to have a 5423A that I paid $60,000 for, and Mark Richards Sr. Actually wrote the software for it.
Yeah, exactly. Yeah, we don't have an acquisition interface for that, but
no, but I've got an interface for my HP. I've got a couple of HP 3560.
okay.
2-channel analyzers.
Okay. Well, what we do on this list here, you can check, you know, from your site if you just go under products and ME scope, and then there's acquisition there. We have our full list of everything that we have an acquisition window for. It's every.
All right.
Basically, we have to get it into ME scope. That's not completely mandatory, but the only other way that we can get into ME scope is if you have, you know, already established database or something like there's maybe you already have acquisition set up and you're collecting into a Pi database or something like that. We can get the data back out and process it in ME scope. But the normal setup is to either buy one of our yellow boxes, which we have, which are in, they're basically like multiplexers. They're 24-channel and 48-channel boxes. They do 4 channels
Okay,
at a time.
and the multiplexer box, what kind of bandwidth and like usable bandwidth and data acquisition rate are they like?
Let me, I can pull up the tech specs for that right now. Actually, hang on just a second.
So I'm thinking about this in a multi-channel, you know, like multi-channel situation.
Exactly, and that's the best scenario for it. I'll tell you what, it is right. No, it's up here more. Let me pull this up. I don't know which one it is. Yeah, so here's some of the signal conditioning. The one we talked about for the box, the multiplexer, it does 4 channels at a time. If you get the 24-channel version, obviously it's 4 channels at a time, 6 times through. 48, you're going to go 12 times through. Does have anti-aliasing. Your spectral resolution, obviously, you can go from whatever it is, 2/1000ths to 800 hertz. But you're going to go at the based on the acquisition rate, which is 4 or 5 seconds or whatever. So.
Okay, so if you want to take, for instance, if you want to look at a gear mesh frequency of say 5,000 hertz.
Yeah.
And a rotor rotation speed on the helicopter of 3 hertz.
Yes.
And you're getting a modulation of the 5,000 hertz by the 3 hertz rotor rotation speed.
Mm-hmm.
Can you zoom in to the point where you can see the side? You can see 5,003 and 4,997.
Yeah. And what you do is you just, I mean, when you're at a operating frequency in a situation like that, and obviously there's a little bit of variability, so the longer you set the acquisition up for, the chance that you have that the operating speed is going to change a hair and you're going to get it a little bit muddied up. But okay. you can set that acquisition up for as long as you want, and obviously the longer that you have it on there and you have a constant operating speed, the higher the resolution you're going to get. But yeah, you'd be able to zoom in there and get better spectral resolution on both sides. But it's pretty good anyway. We got a really good bandwidth. I mean, we can go up to 7, 8, 10,000 hertz, no problem. But obviously, when you set your bandwidth up wider, you're going to lose a little bit of resolution. But
right. I guess the other that brings the question. The next question I want to ask was, how do you deal with variable speed? Because if you're working with absolute values and you're in a paper machine, you're on a dryer bearing on a paper machine.
Yeah.
And the speed is, paper makers going up and down all over the map as far as speed is concerned.
Exactly.
How do you set alarms and so on? Because what I've found in the past is that when you set alarms, because I developed a 64-channel continuous online monitoring system for paper machines in 1985, when engineering used to be a little more difficult. And that was one of the issues, was we had to design the data acquisition hardware so that it would normalize the data. It would track the frequency spectrum. Like the frequency spectrum, I need a normalized spectrum in order to be able to. So you have to divide through by like a roll speed or anything that is a measure, or take the data off the dynamic data off the Toshiba motor controllers. That's how
exactly. Exactly, and that's still basically the way we do it. We do peak tracking. And we try to set up different bands and things like that to try to keep up. But it's still by far the most difficult thing. Everybody that's trying to monitor wind turbines has the exact same problem, and obviously it's the run up and run down that rips those things apart. But it's what everything that's occurring during that run up and run down that everybody wants to know what's going on, and it happens so quickly that it's really impossible to track it.
Wind turbines are tricky.
Yeah. So it's kind of the same thing. We don't even try to pretend to be experts on what you would want to do for alarming and setting in those type of levels, but that's what we do is we set up peak cursors and bands and try to track the peaks within kind of your operating range. So it just depends on what type of range we're dealing with for RPMs. If we're going over, I don't know. I mean, if we're going all the way from startup to a couple thousand hertz, obviously it's going to be more difficult to do because you have to set the band so much wider. But it just depends on what type of variability you're dealing with and how much wiggle room you're going to have as to what you can actually do with it.
Yeah. I found that a lot of machines these days are running variable frequency drives.
Yeah, you're right.
And that's really tricky. Like if you're doing like I've commissioned rubber tire gantry cranes and dockside cranes. Mm-hmm. And of course they're picking up cans and they're running back and forth with and their speeds all over the map.
Yeah, I mean, variable load, everything. It's
You got hoist, you got trolley, and travel and variable loads to pick up different size cans. You've only got a few seconds to grab a snapshot of data, and it's extremely difficult to set any kind of alarms on those things.
Absolutely, yeah, I
Because
agree.
if you're looking for something, and the other, I guess the other part of it is that I like to look at the frequency spectra of the vibration, like on the frequency spectra of the current, like motor current signature analysis.
Sure, sure, and we can get that in there also. Anything that comes in with time records, any type of scalar quantity, we bring that in also. Even with the 48 channel box, we have converters that go on the front end to convert the data, and it passes right through, and then we can put that through in the time waveform. We can, just get your reading in that way. But again, for our particular setup here, we're talking about acquisitions every 4 or 5 seconds, so
yeah,
the load can change considerably in that amount of time. So
yeah, that's where variable speed machinery, especially mobile machinery, like I've worked on wheel motors on like 400-ton haul trucks and things like that, and it's pretty tricky to analyze that kind of stuff.
Yeah, absolutely, it does.
The other question I had was your facts, your fault correlation. What's the T stand for?
Tools.
Tools. Okay.
Yeah.
The fault correlation tools.
Yes.
It sounded like they're based on historical records. You're doing correlation between this is the data today, and then, oh, that's the data that I got when that machine had failed due to imbalance or bad bearing.
Absolutely, that's what it is. Essentially it learns your machine. It becomes more and more effective the longer it's on the machine.
But I guess that sort of begs the question that if I just go and buy a bunch of this hardware and software and set all this thing up on a brand new machine that we've never seen before.
Yes.
Are there any rules that say, okay, this, lots of vibration at 1 times is unbalanced. 2 times in the axial direction is angular misalignment. Lots of multiple rotation speed means something's loose.
Right.
Are there rules built into the database that'll let it look for faults on the gate?
We are actually working on that right now. We kind of have a beta version of that, and it works off of the same rules that you've just kind of indicated. It scours through all the frequency traces and looks for indicators that fit the rules that you've gone off of, which is kind of everybody's standard rules that they've used. You can find all these fault guidebooks out there, and it's very generic in that sense, but that's what it looks for. It's kind of like a mining tool to give you an early indication that way. If it's a new machine, like you said, it's just going to be another one of those tools that's included, that we will make available to go searching that way. But we just don't have it done yet.
I sent Mark about before Christmas, I guess. I sent Mark a copy of our link to our Checkmate automated diagnostic system.
Oh, okay.
I don't know whether you had a chance to look at that or not, but maybe we could talk about that offline if you got a couple minutes.
Yeah, we can.
I'd like to do that. And then as far as how's the pricing work on this? Like, what is it an add-on to ME Scope, or how does it work?
It depends on how you. So, ME Scope, essentially, if you want to use it if you have a copy already, you want to use it as continuous monitoring, or at least set up over a period of time. It's going to need to be at that acquisition site, so either in a yellow box or in one of our multiplex systems. So the downside of that is if you already have that, yes, you can add the option to make it into a MechaniCom capable ME scope, but you're going to lose the ability to use it as a regular ME scope.
Oh, okay. No, I
diagnostics
use it all the time as a consulting engineer.
Yeah. So typically what it is ME scope and MechaniCom are all built in together there. Yeah, I can get you all the pricing for this. We have pricing on 48-channel multiplex box, 24-channel multiplex box. We have pricing. We do offer something now with battery backup, which is kind of nice. Not even battery backup, battery powered, so that if you're out in a civil installation, you want to monitor a bridge, basically there's a program within the computer. The computer will run on minimal power. It'll wake the system up, do an acquisition, and then shut the system back down. And what the batteries are, they're essentially wheelchair batteries, but the capacity on them is really good. You can do, I think it's about 3 minutes worth of acquisition every day, and when the computer shuts down, when that's not running, and it'll run for up to 9 months. So a lot of people go out there and maybe take one acquisition every 3 hours or something like that on a bridge and just have it wake up and then shut back down, and they can leave it out there for a month, no problem, and acquire that data and then bring it back and look at it.
Okay.
Or you can look at it real time in that situation. You can have like a cellular card broadcasting the entire time. You can access it via the internet that way too. So,
have you got strain gauge amplifiers like like Vishay or something like that? Some kind of strain gauge amplifier that you could get you could put a strain gauge on a bridge or on a
if that's a setup that you want to go through, then yeah, I mean that's what we put in as part of the front end. Part of the acquisition, we just change out what we have in there if you're primarily going to run the strain. But yeah, that is certainly available. Like changes like that, customization, it changes the price a little bit, but Vibrant's still a software company entirely. So whatever changes are made hardware-wise, we just pass the cost through to you. We don't mark up anything whatsoever in the hardware side. So everything's passed.
Yeah, because I've got a whole bunch of Vishay strain gauge amplifiers.
Yeah.
And then I've got an FM telemetry system for measuring dynamic shaft torque for torsional analysis.
Right.
So it's a non-contacting system for measuring shaft torque. I use that I commissioned ships in a couple of cruise ships in all America and Italy, and did a lot of diagnostics on plotted propulsion systems as part of a big lawsuit.
Okay.
Yeah. Okay. Well, that's very good. Thank you for the insight into that. I wouldn't mind discussing with you and sending you some information on what I've been up to, and we can make some sense to talk about.
Sure. Yeah, you can send it to me. It's just at Sean.Richardson@vivetech.com. Sean is SHAWN.
Okay.
And I can get it, and we can figure out a time and get together. Yeah, Mark's is mrichandson@vivetech.com.
Okay.
And we can also get you a pricer as well. Get that out to you.
Sorry, Mark, I didn't hear you.
I said we can send you a price list too if you're interested.
Okay. Yeah. That'd be great. I'd like to do that.
A lot of options available.
Yeah, my email is just alees, ALEES, at DSAINT.com.
Okay. Yeah, I have it from the webinar registration.
Yeah. Okay.
Okay, great. Anybody else have any questions? Guess not. Alan, did you have anything else you wanted to ask?
No, I think that's good. Like I said, I'd like to. I think there's some areas there where we might be able to do some collaboration. There's I've got some ideas I'd like to discuss with you, but obviously we should do that offline sometime.
Okay, let's do that. We'll set something up for sure.
Okay.
Very good. Well, if nobody else has anything, we'll go ahead and wrap it up here. And thank you guys, and keep a lookout for newsletters from Vibrant. We have webinars every month, both on Emiscope and MechaniCom. And we'll end it with that. Thank you guys for attending. Have a great afternoon.
Yeah, thank you, Mark. Thank you.